Welcome back, Chappelle. Welcome back to it. Welcome back to your flipped classroom and our now enduring, continuing discussion about this really intense unit that we've been talking about, right? So this whole unit is actually based on basically the developments in Europe that are going on from the 1500s into the 1600s that are going to lead to some other major causes going into this era known as absolutism, right? But the thing about it that we're doing right now, as you can tell, we're being easy, we're being copacetic, we're not screaming, we're not freaking out. B period, great job day. C period, great job day. For all the kids that missed my class on the sudden impact stuff, make sure you get your stuff back from other classmates and make sure that you're all caught up and stuff like that, right? So the big thing about it was really chill in C period today. Very, very nice and light and stuff like that. We enjoyed it. But the big thing about it though in general when we're looking at it, something we need to understand is that this thing that we're about to talk about, the scientific revolution, was going on at the exact same time as the era of the exploration, right? And so what we're going to do now is we're just going to take a nice, easy slide into the scientific revolution, right? We don't need to yell. We don't need to scream. We don't need to freak out. We're just going to have a good time with this and get after it, right? I love talking about the scientific revolution. It's one of my favorite time periods in European history. It's going to be an era from about like the 16th century up until about early 18th century where major developments in scientific thought and theory are going to be developed, causing massive new changes and very, very interesting political changes even later on. We get into the Enlightenment and the rationale of questioning and things like that in Europe and also in Western civilization's history. But the scientific revolution, a lot of it, especially the early parts of it, really hinged around the ideas of changing our views of the universe, right? So this is a title, by the way, for each one of these. I'll tell you if it's a title or not, but this is a title, okay? So one of the big things that's going to change in the views of the universe is where we believed that Earth's place in the universe was. Y'all, when y'all were younger, you learned a lot of stuff in elementary school, and you were far smarter than the average European in the 1400s in the sense of your understanding of where the Earth is, how many planets there are, where they go, that they go around the sun and things like that. Because the thing about it is that early views of the universe, including people like Ptolemy, Aristotle, some of the ancient philosophers, Socrates, Plato, all those guys who were the smartest men of their era and the smartest men of their times and the smartest people, some of the smartest people that walked the face of the planet while they were alive, they all were wrong and they all believed, or for the most part, in a geocentric orbit. Now, not all of them. There was this guy named Samus of Thrace, who was a very, very ancient Greek philosopher, and he was born around 300 AD, and he even believed that we went around the sun and stuff like that. So it wasn't everybody, but the prevailing minds of the day believed in what is known as a geocentric orbit, all right? And what a geocentric orbit is the concept that the Earth is stationary in the middle, and that the Moon, Mercury, Venus, and all the other planets go around the Earth while we sit still. Now, really quickly, do we blame them for this? Not particularly, right? You have to understand they're using very, very simple powers of naked eye observation, right? They're looking up into the sky, they're seeing everything move, but they feel as though they're stationary, so of course they're going to believe in this geocentric orbit idea, right? Even in the School of Athens that I know all of us really enjoyed when we did our Renaissance art stuff, Ptolemy is in the bottom right corner holding a sphere of stars in his hand because that's what he believed, is that literally the Earth was inside of a bigger sphere, of course, that actually had holes on the outside of it and the light of heavens was shining through it, right? They're using their simple powers of observation. They're opening their eyeballs, looking into the sky and being like, I wonder what's going on up there. Maybe it's this, right? And the thing most of them concluded on was that geocentric orbit, the idea that the sun and the other planets revolve around the Earth and not the other way around. Now, because of the fact that these ancient philosophers are going to put these theories forward and they're going to start having these questions and start considering these different ideas and stuff like that, you have to understand that this is going to catalyze itself after the fall of Rome and into the Middle Ages, when the church became the dominant intellectual power in Western Europe, and then also, in Europe, and then also in Western civilizations in general. So the church, remember, was the home of the people who could read write and do all these other things during the medieval era. So the church would also try to explain the universe, and they are going to adopt the same theory. They believed in a geocentric orbit as well. The church during the Middle Ages thought that the earth was stationary. Some of them thought actually it might have been flat because it says that in the Bible. But the thing about it, though, in general, is they thought the earth was stationary and that all the other planets and spheres and items revolved around us. Now, the church took it a step further, and they also tried to say, oh, well, angels are pushing the planets and all those different things all the way around us. Look at them go, right? They're moving them all around us, and it's actually more about the ideas that the divine creators, God, Christ, and the angels in heaven are moving the planets freely around us while Earth remains completely still. This right here is an actual mosaic tile work and a piece of art from the Middle Ages, and you can actually see angels pulling planets around the Earth in the middle, right? So we know now that that's not right. We know now that this is not correct, okay? They're not teaching you this in 5th grade being like, yes, and the earth is stationary. The actual first guy, though, that comes along in the 1530s, and I believe it's in 1534, let me double check, is going to be a man by the name of Nicholas Copernicus, right? So Nicholas Copernicus is going to be the very, very first scientific thinker that we interact with during the De Revolutionis Orbitum Celestium. Now, so when does he publish this book? 1543, nice. So the thing about it is, Nicholas Copernicus, right, is going to be the very first scientific thinker we think of. Or wait, excuse me. Nicholas Copernicus is... Let's try that again. Nicholas Copernicus is going to be the first major scientific thinker that we interact with during this time period, right? Nicholas Copernicus is going to publish a very, very famous book in 1543 known as De Revolutionis Celestial Orbitum. And the thing about it is what that means in Latin and stuff like that is his book actually said on the revolutions of the heavenly spheres, right? Basically saying what's going on outside in space, where are these spheres are going, and how are their orbits working, where are we going? Well, he's the very first one to propose the idea in his book known of as a heliocentric universe, right? The idea that the sun is actually stationary and all the other planets revolve around it. He also looks exactly like Lord Farquaad from Shrek, but his book is going to be massively important, okay? And as you can see in this diagram inside of his book, he has the sun actually stationary and all the other planets going around it, right? So he is the very first one to actually introduce this concept of the heliocentric moment and the heliocentric pattern of the universe. And when he does this, he actually published his book. This is a great little fact that'll help you answer about him on your test. He published his book and he died only a couple of days later, right? Now, some people, of course, romanticize this a little bit and say he wanted to avoid being persecuted by the church and like stuff like that, which may very well be true. But he did die only a few days after publishing De Rev, is what a lot of people call it in like colleges. College professors will refer to it as De Rev rather than actually referring it as De Revolutionis Celestial Orbitum. Now, so the big thing about it is, though, in general, is that Nicholas Copernicus is the first guy to come along and propose this idea of that heliocentric universe. This was his model, right? He believed that, no, the sun is actually stationary and Mercury, Venus, Earth, Moon, Mars, Jupiter, all the other guys go around the sun, which we know now is the correct movement. But the thing about it is he had to deal with the fact that most people didn't believe in this, right? Most people that were of the era were priests, monks, and other thinkers that existed inside of these universities that were based off of monasteries and then also off of large churches and cathedrals, right? And the thing about it is that they had held fast for a long time to the geocentric model of the universe, so they're not just going to drop what they're doing and just pick up this heliocentric model, this idea that the earth revolves around the sun. So the thing about it is a lot of experts at the time, including the people that worked in the church, then also the thinkers of the era that came before him, are going to reject his theory. Now, interesting little thing about it, he's not even the very first person to come up with this. There was this French scientist named Nicolas Oraim who actually came up with this theory as well a couple decades before he did, but he never got to publish his stuff, right? We just have some of his writings and things like that. We have several other ones like the guy I said earlier, Samos of Thrace, the dude from the ancient eras, like from ancient Roman Republic, but he was actually Greek himself, even also thought in the heliocentric idea, right? So it sounds to me like there are a lot of people that are experts that also think that the heliocentric model was right. But all the people that worked in the church and the thinkers of the era are going to reject his theory. Why, though? Why do they all sit there and reject it? One, because you don't want to abandon things that it says in the Bible. And then two, because of this stupid, idiotic motion
that the planets make and have an optical illusion, okay? What I'm about to tell you right now is going to be very, very important. And I need you to listen very carefully because I don't need people telling you ridiculous things that don't actually happen for the rest of your life, right? Why did a lot of these experts say this? Well, they were like, all right, Nicholas, if heliocentrism works, then explain to me retrograde motion, all right? So now look, in certain parts of the year, all right, when you look into the night sky, what will happen is certain planets will appear as though they're going backwards, right? That right there is retrograde motion, right? They'll look like they're going backwards because of the angle of the sun, our position, and then the position of the Earth in our observational perspective. The thing about it, though, is it's not moving backwards. People today, literally to this day, believe that the planets moving backwards in an optical illusion affects their feelings and what happens in the day-to-day society. I hate to break it to you, but Mercury being in retrograde has been disproven for hundreds of years, all right? And then also, in a nutshell as well, the thing about it is it's not actually going backwards, it's just an optical illusion. So obviously you can tell I get very hyped up about this, all right? But the people of the era said, no, Nicholas Copernicus, it doesn't make any sense because you don't know what a retrograde means, because he couldn't disprove that, right? And then also, look at Pluto being picked on by the other planets. Poor Pluto. Now, the big thing about it, though, in general, is you have to understand is that Nicholas Copernicus' theory goes out there, but the thing about it is it does take some time for it to kind of catch on a little bit, right? Because the next scientific figures that are going to come after Nicholas Copernicus are going to actually put forward a lot of theories that help prove his concepts and also provide tons and tons of a very all-important thing, data. Now, the thing about it, though, is also Nicholas Copernicus couldn't really actually argue these things. He couldn't say, oh, I think about this and I think about that. The Polish scientist, the man that we know is Nicholas Copernicus, like I said, died a couple of days after his book was actually published. Now, the next guy that's going to come along after it, a very eccentric Danish man by the name of Tico Brahe, is going to be very, very important in the structure and understanding of the universe. This is Tico right there. We'll talk about the thing that's sitting next to him here in about 2 seconds. The thing about it, though, is Tico Brahe was a genius. Tycho Brahe was a very, very, like a genius, a man of his time, a man of his era, and the thing about it is he didn't even believe in Copernicus's ideas, right? He actually came up with this thing called the Tychonic system, where he believed that the Earth was still stationary and the planets were doing other weird stuff. So why is this guy important if he's actually not correct? Well, the reason being is because he is the last of what is known as the naked eye astronomers, right? An astronomer that's using no telescope, using his eyes and plotting the movement of stars and planets. He was so smart, in fact, that apparently the Danish king literally bought him an island and said, look, I'm going to buy you an island, big fella, off the coast of Denmark. Don't leave. Don't go to the Holy Roman Empire. Don't take your talents somewhere else. Look, I'll buy you an island. It's right here. We'll build an observatory on it. We'll build another laboratory on it, and you can have it, and you can just go nuts, right? You can go nuts and just be smart all over the place, right? And so at a massive amount of expense, the Danish government paid Tycho Brahe to just sit all day long and look at the stars and figure out the position, movement, and other things that are going on with them, right? Fun fact about Tycho Brahe, though, as well, he was a little bit of a weird guy, right? He was very eccentric. He was actually missing the tip of his nose because he actually got it cut off when he was having a duel with his cousin about a math problem. That right there is his prosthetic nose that he would actually glue onto his face every day. And if he ever got any frustrated or a little bit too drunk, he would sweat and then it would fall off into his plate and stuff like that. He also had a pet elk that lived with him, and then one day the elk fell down the stairs and died because it got drunk at a party. But that's a whole other thing for another time period that we'll talk about as well. But Tycho Brahe is a big weirdo. But he would also sit down and just look into the night sky and figure out, all right, that star is right there today. Where will it be tomorrow, right? Where will it be in a couple of hours? What he's doing is accruing a ton of data, right? And another big thing he saw a star being born, right? He was looking into the night sky one evening, and all of a sudden, he noticed a star he had never seen in the sky, and it was brighter than all the ones around it. It had tails on the end of it and stuff like that, showing that it was emitting a huge amount of light. What he saw in that moment was he saw a star at the beginning of its life going supernova, right? Emitting a ton of light. And what he realizes, he's like, oh, wait a minute, hold on. The ancient philosophers, Aristotle, Ptolemy, all those guys are wrong about one thing. the things out there are not perfect. They're actually chaotic and moving and bashing into each other, and things are exploding and being born and dying, and all of these different years and years of like analyzing the stars. He analyzes them and actually says, wait a minute, I'm going to write all this down. And he actually writes it all down in this thing known as the Rudolphine tables, where he tracks the movement, location, and pattern of 777 different stars and how they moved around through the night sky, right? That's a ton of data that this guy is getting together. But then his assistant that comes along a little bit later, a man by the name of Johannes Kepler, takes all this data after Tycho Brahe dies, and he uses that data to realize, wait a second, I know the movement of all these different stars because of Tycho Brahe. I know where everything is going because of Tycho Brahe. I know all this different stuff because of this man. What I need to do right now is I need to figure out how to use it, right? And so he is the assistant to Brahe that would come along, and he realizes, wait a second. Copernicus was right the entire time. It is a heliocentric pattern. It has to be a heliocentric pattern because all this data shows that the perfect way to fix it is instead of having circular orbits, you make them elliptical or ovals instead. And that will fix the retrograde motion problem. It will demonstrate that it's an illusion, and it will help prove mathematically in 1609 that the heliocentric universe is correct. But the thing about it is, even after Kepler comes along and says that the the orbits are actually ovals, people still didn't believe until this guy came along. And that man's got a name, very, very famous, and that guy's name is Galileo Galilei, right? And Galileo Galilei is going to come along, and he is going to be the Italian scientist that proves heliocentric design because he uses his telescope to like analyze comets, the moon, the moons of Jupiter, and other major moving bodies. And he realizes a very all-important thing, that there's a size relation between heavenly bodies and the mathematics that will help prove heliocentric models. But we'll talk more about Galileo in class tomorrow. I'll see you guys then. Y'all have a great evening. We'll crush this stuff. You'll have one more flip before your test, and then I'll see y'all soon. Y'all have a good one.